Hello everyone, and this is the last video I'll be doing on statistics papers, thankfully. The last one I've got to do is question 4, discrete random variables, well really binomial distribution and hypothesis testing. Now this normally comes up in the AS paper, it has every single other year, but last year it came up on the A2 paper, and so be aware they can ask you a hypothesis testing question on a binomial distribution. They did last year, maybe they will in your year as well. It's while some things often come up in the AS, they can ask them in the A2, and so you've got to be on your guard. Anyway, what have we got? We've got a dentist, past records, 10% of customers arrive late for their appointment. A new manager believes there's been a change in the proportion of customers who arrive late. A random sample of 50 of the dentist customers taken. Okay, write down a null hypothesis corresponding to no change in the proportion of customers who arrive late. In other words, it's still 10%. Now this is 0.1 and this is p, not rho. This is not like a correlation coefficient hypothesis test. Right, the manager's belief is that it's been changed. Yeah, so I'm afraid this is going to be two-tailed, which nobody likes, and so this is just probably it doesn't equal 0.1. Okay, now this is a tricky question. I just glanced at it and I could see it was a tricky question when it was two-tailed, and it wants the probability in rejection at each tail, which should be less than 0.025. Okay, we've got to find a critical region. I think that's always harder to do on a calculator. Now the way I'm going to show you this, mainly because I haven't got a calculator, I'm going to use an online binomial distribution calculator, but I'm going to point out what you would be doing. Yeah, we're going to try and make sure the tail, the probability in each tail is as close to 2.5% as possible. Now, the way I do this on a calculator, or the way I encourage students to do it, write down the binomial conditions. Yeah, it's going to be 50 trials, isn't it? 50 people, yeah, 50 trials, and p is 0.1 because you always assume the null is true when you're testing this. Yeah, and we're trying to find the critical region. Now, I honestly would encourage you to guess where you'd roughly think it should be, and it should be quite an extreme result. Now, you'd expect with 50 and 10%, you'd expect 5 to be the most common, so it would be much less than 5 and slightly more than 5 for your tails which you're testing. You're going to use binomial CD. Yeah, on a calculator, I would look up if the expectation is 5, because 0.1 times 50 is 5. I'd go with like something like 2, and I'd try and find the probability that x is less than or equal to 2. Yeah, now you'll be doing binomial CD, you'll be plugging in those values, and you'll be finding it. But I'm going to have to use this online calculator, so let's have a look at it. So I'm going to put in probability was 0.1. Number of trials is 50, and then I'm looking for 2. Now, on this calculator, it will tell me the probability of exactly 2, but also less than or equal to 2. Look at this, it's 0.112 essentially. Okay, so this is too large, yeah? But I encourage people to guess, yeah? So that's too big. So I'm going to go down to less than or equal to 1 next, which I suspect will still be too big. Let's have a look. So this time I'm going to take it down to 1. Okay, probability of one event, that's 0.028, sorry, 0.0337, because I need less than or equal to 1. So 0.0337, well, that's 0.034. That's still too big, yeah, because it's bigger than 0.25. And so I'm going to have to go with 0. You can write equal to or less than or equal to. I'll write less than or equal to just so you can see. I guess that this is just going to be just under. And what do I get? Let's have a look on my calculator. It talks about the p-value as well. That's good, because this question does that in a second. Let's calculate it. Okay, we get 0.005. Okay, and that is under 2.5%. And it says it should be less than 2.5%. This is less than 0.025. And so x is less than or equal to 0 is critical. Yeah? That's where the critical region begins, because the critical region begins when the probability is less than 0.025. Now, the upper end of the scale is harder, I'm afraid. Not on something like what I've just been using, because it's actually easier to see what's going on. But for the, and you can make this easier for the examiner. Call this the lower tail, yeah, because the lower tail is always easier, and it's easier because your calculator works for less than or equal to. The upper tail is harder, yeah, because if you're going to look for the probability that x is greater than or equal to a number, well, you have to do 1 minus the probability that it's less than or equal to it. Now, I'm going to guess that it'll be kind of symmetrical around 5, so I reckon it's going to be around 9 or 10. Now, the probability that x is greater than or equal to 9 is 1 minus the probability that it's less than or equal to 8. So I would have to work that out on a calculator, and that's going to be, on my one, let's actually work this out. Okay, I'm just going to look at the less than or equal to one to try and help you. That's 1 minus 0.942, which is obviously 0.058, yeah? That's bigger than 0.025, so I'm going to have to try 10 next. And that's 1 minus the probability that x is less than or equal to 9. And what does that come to? Let's find out. Change this to a 9. And this is what you'd have to do on your calculator. Okay, I get 0.975. Oh, and let's be a little bit more precise there, because let's see if it genuinely is under 0.97546. 97.55. So this is just under, I think. Yeah, look, 0.97546. And so that's going to give me 0.02454 basically. And that's just under 0.025, and so x is greater than or equal to 10 is critical. We've now found the two critical regions. That's tricky because, I always encourage my students to guess, but they always have trouble guessing where they should be guessing. Remember, you've got to do the 1 minus. It's awkward, it really is. So we've found a critical region. Find the actual level of significance for the test based on your critical region to part B. What is the actual significance? And what's another word for this? It's the p-value, yeah? The p-value is the actual significance of the test. You just add your probabilities here. Let's do it with a highlighter. Here and here. That's all we're going to do to find the actual significance. So the actual significance is going to be 0.005 plus 0.02454, and that comes to, and try and work as precisely as possible, okay, I make it 0.0294, 2954. Okay, that's interesting. Okay, so that's the actual significance. And then finally, the manager observes that 15 of the 50 customers arrived late for an appointment. With reference to part B, comment on the manager's belief. Well, 15 is a critical value. So this supports the manager's belief, doesn't it? Because the manager thought that the probability had changed, and this is in the critical region, so it looks like you'd be accepting the null hypothesis, sorry, alternative hypothesis, that the probability isn't 0.1 anymore, it's changed. So this supports the manager's hypothesis, or manager's belief. There we go. Okay, let's see how we did. Where's the answers? It's over here somewhere. Did we get them right? Okay, brilliant. 0.0297 was what I wanted to look at. I've got a rounding error here. Look, I've got 0.02954. It's because of this. I've rounded this. Don't be me. Don't introduce rounding errors. Try and work in a paranoid way to 3 or 4, like, basically beyond the accuracy of the answer that you need, so that your final answer is accurate. But everything else looks fine. Okay, so I hope that video was useful and you can see what's going on. Apologies, but I haven't got one of your calculators to work with, but I hope you could see what I was doing with the online calculator there. Okay, keep up the hard work and bye bye.